Welcome to General Physics 1. So today we're going to have another example applying force, so examining the force that is acting on a pulley system. So here we have mass 1 and mass 2, wherein mass 1 is resting on top of a frictionless table and mass 2 is hanging vertically. So the problem is we have two masses that are connected, so as shown in our diagram. So mass 1 is equal to 10 kilograms. This is 10 kilograms. And our mass 2 is 20 kilograms. So assuming a frictionless pulley, so determine the acceleration of the system. So we need to solve for, to construct equation for the acceleration. And we need to look for tension experienced by this string or by the cord. So we also need to look for an equation to solve for the tension. So step number 1 natin, of course, is to create a free body diagram. So since we have here two objects, two masses, so let us have two free body diagrams. So for mass number 1, for our mass number 1, so since this is resting on a frictionless table, therefore there are no opposing force. So yung normal force and our force due to gravity is canceling each other out. So the summation of forces along the y-axis for mass number 1 is 0, and for the horizontal axis we don't have an opposing force here. So therefore the force that is acting in this mass is only the force of tension. Ayan. So therefore, summation of force. So equation number 1 natin, our summation of force along the x-axis for our mass 1 is equal to tension force. So from Newton's second law, sabi natin net force is equal to mass times acceleration. So we can substitute this to this term. So therefore, tension force, or we can just write it as T. So if you want, so we can just use T instead of F of T. So tension force is equal to, so palitan natin yung summation of F of X ng mass 1 times the acceleration. So now we have our equation number 1. Equation number 1. So next is, let us analyze our second mass. So the forces acting on our mass number 2. So we have our mass, which is hanging vertically. So this is our mass number 2. So what are the forces acting to this mass? So we don't have horizontal force. So what the force acting to it, so the external force, we have here the force due to gravity, or is equal to the weight, and then we have here the tension force. So this, since since this object is accelerating, so since this is frictionless, so sabi natin this is frictionless. So if this object here, so this object here has greater weight compared to this mass number 1. So therefore, we expect this to accelerate to this direction. So since our direction of acceleration or motion is downwards, so we assume the downward direction to be positive and our upward forces to be negative. So therefore, the summation of forces along y-axis here is equal to force due to gravity minus our tension force. So from our equation number 1, we know that tension force is equal to mass 1 times acceleration number 1. So summation of force along y is equal to Fg. So substitute natin to with this. So we have mass 1 times the acceleration. So from Newton's second law, we can substitute this one. So substitute natin itong summation of F of y with mass times acceleration. So, anong mass ang gagamitin natin? So, since this is the net force acting on mass 2, so mass 2 times the acceleration of the system is equal to Fg minus m1 times the acceleration. So, hatiin natin dyan. So we need to look for the equation for acceleration, and we need to look for the equation for tension force. So here, to look for the equation for the acceleration, so combine natin yung like terms, and then isolate natin si acceleration. So we have Fg. So we transpose this to the other side, so that we have mass 1 times acceleration minus plus mass number 2 times the acceleration of the system. So, by distributive property of multiplication, we can simplify this. So, ilalabas natin si A. So, A times mass 1 is equal to mass 1 times A plus A times mass 2. Asan na? Yan, mass 2 is equal to this one. So, to isolate our acceleration, so divide both sides by our mass 1 plus mass 2. Yan, mass 1 plus mass 2. So, yan. So, therefore, our acceleration is equal to the force due to gravity divided by our mass 1 plus mass number 2. So, we have now our second equation. Okay, so let's copy this equation number 1 and equation number 2. So, punta tayo sa next slide. So, kopyahin natin yung tension. So, to look for the acceleration, sabi dito, acceleration is equal to force due to gravity divided by mass 1 plus mass 2. So, this is based on our analysis of the free body diagram. And then, sabi natin, yung tension natin is equal to mass 1 times the acceleration of the system. So, times the acceleration. So, let us now solve for the acceleration. So, letter A. So, acceleration is equal to force due to gravity. So, ang force due to gravity is mass. Ay, sorry, nawala. So, ulitin natin. Sulat lang natin. Okay, so let us now answer our problem number 1. So, acceleration is equal to force due to gravity. So, the force due to gravity here is the weight of our mass number 2. So, this is, so from our previous slide, so from our analysis of the free body diagram, so itong force na to, force due to gravity, is the force that is acting to mass number 2. So, therefore, to solve for the force here due to gravity, so we multiply mass 2 to the acceleration due to gravity divided by mass 1 plus mass 2, or the total mass. So, mass 2 is, sabi natin, this is 20 kilograms and mass 1 is 10 kilograms. So, 20 kilograms times 9.8 meter per second squared. Kuha lang ako ng calculator. Okay, so here we divide it by mass 1 plus mass 2. So, mass 1 natin is 20 kilograms. Not times, plus 10, or mass 1. Mass 1 pala natin is 10 kilograms. Okay, so mass 1 is 10 kilograms plus our mass 2, which is 20 kilograms. Yan. So, 20 times 9.8 is equal to 196 Newton divided by 30 kilograms. So, the acceleration, so ayusin lang natin yung pagkakasulat. So, it lang. Okay, so, 196 divided by 30 kilogram is equal to 6.53 meter per second squared. So this is the acceleration of our system. So this body M2 is accelerating downwards with by 6.53 meters per second squared, and this one is accelerating to this direction by 6.53 meters per second squared. So what is now the tension experienced by the string? So to get or to solve for the tension, we use this equation where T is equal to mass 1 times the acceleration of the system. So we have now the value for the acceleration. So mass 1 is equal to 10.0 kilograms, and the acceleration of the system is 6.53 meter per second squared. So 6.53 meters per second squared times 10 kilograms is equal to 65. So the tension force experienced by this string is 65.3 newtons. Okay, so that's all for this example. So now we have this final answer for the acceleration of the system, which is equal to 6.53 meter per second squared, and the tension force, which is equal to 65.3 newtons. So the tension force here and the tension force of this part of the string is equal, and the acceleration of the system is the same. So accelerating downward and accelerating to this direction. So ito yung value nila. So that's all for this video. So in our next video, we are going to discuss forces acting on a body that is rested on an inclined plane. So see you and goodbye.